Okay, good morning. Am I audible? Hello? Am I audible? Hello? Am I audible?
Yes, sir.
Okay, fine. So on Tuesday, I took one offline class. Around 23 students were present on that day. Anyway, welcome to the online class. So let us start the first module, hydrology. So the part you have two parts. Part A is hydrology. The part B is irrigation engineering. So let us start with the part A, the first module. So now hydrology. So let us define what is hydrology. So hydrology is a science which deals with occurrence, distribution, and circulation of water from the planet Earth. So hydrology is basically, it's an earth science which deals with the occurrence, storage, distribution and disposal of water on the planet Earth. So all of you know about what is the hydrologic cycle which occurs in the nature. So please mute. So hydrology is a science which deals with occurrence, distribution and circulation of water from the planet Earth, or else you can define it also. Hydrology is an earth science which deals with the occurrence, the storage, the distribution and disposal of water from the planet Earth. Now, so here this table gives the world water resources. What is the total world water resources? The total world water resources is estimated as 1.386 million cubic kilometer, or it is 1.38 into 10 power 6 million hectare meter. So it can be either 1386 million cubic kilometer, or it is 1.38 into 10 power 6 million hectare meter. So out of this total world water resources, global water resources, about 97.2% is salt water, which is mainly held in ocean. And only about 2.8% is available as fresh water on the planet Earth. So out of 100%, about 97.2% is salt water, which is mainly in ocean, so that we cannot use that salt water for drinking or any irrigation or other purposes. Only about 2.8% is available as fresh water. So even out of this 2.8% of fresh water on the planet Earth, about 2.2% is available as surface water and 0.6% as groundwater. So out of this 2.8%, about 2.2% is treated as surface water and about 0.6% is treated as groundwater. Now you can see even out of this 2.2% of surface water, you can see 2.15% of surface water or fresh water is held in glaciers and ice caps. So out of this 2.2%, again 2.1%, 15% is the water which is held in glaciers and ice caps, and only about 0.005% is available as fresh water in lakes and streams. So now you see the percentage of fresh water that is available in the streams and lakes. It is of the order of 0.005%. So since the water requirement is increasing day by day, so the available fresh water in lakes and streams is to the order of about 0.005%. So available water has to be used very scientifically and economically. So now even out of this 2.2%, 2.15% is held in glaciers and ice caps, and only about 0.005% is available as fresh water in lakes and streams. And even out of this 0.005%, about 0.001% is fresh water that is available in lakes and streams, and the remaining 0.004% will be in the other forms like fog, mist, dew, like that. So now out of this 0.6% groundwater, only about 0.25% can be extracted with the present drilling technology. So even out of this 0.6% of groundwater, only you can extract about 0.2%, and the remaining percent of water remains as a deep storage, so that it cannot be taken out and it cannot be used for any purposes. So this is the current, that is the statistics of the world water resources. So either it can be 1,386 million cubic kilometer, or it can also be 1.38 into 10 power 6 million hectare meter. Now this Tableau column gives the water potentials of our country, that is in India, the water potential in million meter cube, and these are the water bodies. Now, in India, we have many major rivers flowing right from north to south. In northern India, we have rivers which are perennial. Perennial, that means you have sufficient flow throughout the year. So in the southern parts of India, the it is peninsular India. Here, the water is available only during the rainy season, So the remaining part of the year, you don't have any flow in the rivers. So whatever the water that is available in the rainy season, it has to be stored in ponds or in reservoirs, so that the same water can be utilized for various purposes. So generally in southern India, we have many dams which are constructed across the rivers. So the main purpose of constructing these dams are to store the water during the monsoon period, and the same water can be utilized for various purposes like irrigation or domestic and industrial water supply or power generation or inland navigation or fish culture or any other purpose. So hence a reservoir constitutes a multi-purpose project because it serves more than a single purpose. So this table gives the total water potential in our country, in India. So we have major rivers flowing in our country. So the west flowing rivers, that means we have our country is surrounded by oceans on three sides. That is, on the west side we have the Arabian Ocean, on the east side we have the Bay of Bengal, and at the bottom we have the Indian Ocean. So here the west flowing rivers are Narmada and Tapti, and its water potential is about 30.55 million hectare meter. It is not meter cube, so there is a mistake here. The water potential will be expressed in million hectare meter. So the west flowing rivers, that is in Gujarat, that is rivers like Narmada and Tapti, and the water potential is about 30.55 million hectare meter. And the east flowing rivers, that means which joins the Bay of Bengal, so like Mahanadi, Godavari, Krishna, Kaveri, Tapti, so it accounts for about 35.56 million hectare meter. And in the northern parts of India, we have Ganga and its tributaries. So you can see the Ganga and tributaries, it constitutes about 55.01 million hectare meter. And in the northwestern part of India, we have the Indus and its tributaries, which accounts for about 7.95 million hectare meter. And the Brahmaputra river, which accounts for about 59.07 million hectare meter. So if you add all this, so the total water potential in our country is about 188 million hectare meter. So this Tableau column. Anyway, I will be sharing the notes to all of you. So there is a printing mistake here. Anyway, so these are the water potentials of various rivers flowing in our country: the west flowing rivers, the east flowing rivers, the Ganga and its tributaries, and Indus and its tributaries, and Brahmaputra. So now I have shared the figures. Regarding the hydrologic cycle. I think all of you have received that through WhatsApp. Hello. ನಾನು ಹೈಡ್ರಾಲಜಿ ಸೈಕಲ್ ಇಂದು 3 ಫಿಗರ್ಸ್ ಕಳಿಸಿದ್ದೀನಿ. ಎಲ್ಲರಿಗೂ ಸಿಕ್ಕಿದೆಯಾ, ಬಂದಿದೆಯಾ? ಹಲೋ.
Yes, sir.
ಓಕೆ. Now we have discussed what is the definition of hydrology. So hydrology is an earth science which deals with occurrence, storage, distribution, and disposal of the water on the planet Earth. And we know the global water potential that is about 1.38 into 10 power 6 million hectare meter. And what is the water potential of our country? It is about 188 million hectare meter. Now, how do you get water? How do you get water? We get water from nature, correct? We cannot create. So total, basically, the whole universe is based on two concepts. That is conservation of mass and conservation of energy. So energy can be converted into one form to the other. Similarly, the matter can be converted from one form to the other. So similarly, we get water from the atmosphere or from the nature. So now, hydrologic cycle. Hydrologic cycle is also called as a water transfer cycle. Water transfer cycle. So this cycle continuously occurs in nature without any permission. So hydrologic cycle is a water transfer cycle which occurs continuously in nature. So now there are three important phases of hydrologic cycle. One is the evaporation and evapotranspiration. So evaporation is nothing but the water evaporated from free water surfaces like ponds, lakes, reservoirs, and ocean. And evapotranspiration means the water lost to the atmosphere through plant leaves, crop land, or irrigated land is called as evapotranspiration. So this is the first phase of hydrologic cycle. So there are three important phases of hydrologic cycle. The first phase is evaporation and evapotranspiration. The next one is the precipitation, it is also called as the rain. Precipitation is also called rainflow. And the third one is runoff or the overland flow. So these are the three important phases of hydrologic cycle. Now, water in ocean evaporates due to the energy provided by solar radiation. Because of the solar radiation, water from the ocean evaporates. The water vapor moves upward and forms clouds due to its low density, because whatever the water that evaporates from the free water surfaces, due to its low density, it rises to the sky, which results in the formation of heavy clouds, dense clouds, and these clouds burst or sometimes it collides with each other, which results in the form of precipitation. Now you can see here, water in ocean evaporates due to the energy provided by solar radiation. The water vapor moves upwards and forms clouds, which while, sorry, there is a sentence mistake here. So basically, the water vapor rises to the sky due to its low density and at higher altitude due to the condensation of nuclei, so which results in the formation of dense clouds. So these clouds collide each other, or sometimes it bursts, which results in the precipitation, correct? Which results in the precipitation of different forms. So the precipitation may be of different forms, like it may be rain, drizzle, or snow, mist, fog, dew, etc. So these are the different forms of precipitation, whether it may be rainfall, or it may be drizzle, or it may be snowfall, or it may be mist, fog, dew. So these things we'll discuss in detail in the subsequent chapters. Now, a part of precipitation may evaporate back to atmosphere even while falling. Another part may be intercepted by vegetation. So what does this mean? Means when a rainfall takes place, some portion of the rainfall will not reach the ground surface, which will be returned back to the atmosphere, due to interception by the forest vegetation. That means whenever a rainfall takes place, not entire rainfall will not reach the ground surface. Some portion of the rainfall will return back to the atmosphere due to the forest vegetation. So this is called as the interception loss. This portion of rainfall which will not reach the ground surface and which will be returned back to the atmosphere without reaching the ground surface is called as interception loss. So after interception loss, the remaining part of the rainfall falls on the ground surface, falls on the ground surface, and some portion of the rainfall, flows over the land, that is called as the overland flow. So the other part of rainfall which infiltrates into the ground surface, into the ground, and which builds up the groundwater table. So whenever a rainfall takes place, some portion of the rainfall will not reach the ground surface. It will be returned back to the atmosphere, which is called as interception loss, and the remaining other part of the rainfall will infiltrate through the ground, and which will build up the groundwater table, and some portion of the rainfall will flow over the land, so which is also called as the runoff or overland flow. So this runoff or overland flow, when it flows over the ground surface, it fills the depressions, whatever the depressions in the ground surface, whatever the depressions are like ponds or lakes, and after filling all these depressions, the remaining part flows over the land surface and finally joins the ocean. So a part of precipitation may evaporate back to atmosphere even while falling, another part intercepted by wind. So mute ಮಾಡ್ಕೊಳ್ಳಿ, please. Now I have shared the hydrologic cycle figure to all of you. So it is self-explanatory. One is the general form of hydrologic cycle. The second one is Harton's qualitative representation of hydrologic cycle. And the third figure is the engineering representation of hydrologic cycle. So I have shared all these three figures to you. So in the examination, they may ask a question, explain the hydrologic cycle, that is general form of hydrologic cycle. You have to write the first one. So the second figure corresponds to the Harton's qualitative representation of hydrologic cycle, and the third figure corresponds to the engineering representation of hydrologic cycle. So basically, hydrologic cycle is a water transfer cycle which continuously occurs in nature, and it is a continuous process. It is a never-ending process, and there are three important phases of hydrologic cycle. One is the evaporation and evapotranspiration, and the second one is the precipitation, and the third one is overland flow or the surface runoff. So we engineers are much concerned about the third phase of the hydrologic cycle, that is whatever the water that flows over the land surface or the overland flow, or it is also called as runoff. So after filling all the depressions on the ground surface, the excess water finally joins the stream or river. So whatever the water that joins the stream or river, so which can be stored by constructing a reservoir across the stream, so that water can be stored on the upstream side, and the same water can be utilized for various purposes. Now we know the process of hydrologic cycle. How does it happen? So that means water evaporates from the free water surfaces like lakes, ponds, and reservoirs and the ocean. And these vapor, because of its low density, which rises to the sky at higher altitude, so these water vapors are condensed due to the condensation of nuclei, so which results in the formation of heavy clouds or dense clouds. So these clouds, sometimes it melts or sometimes it bursts, which results in the precipitation or rainfall. So whenever a rainfall takes place, some portion of the rainfall will not reach the ground surface, which will be returned back to the atmosphere. That is called as the interception loss. So the remaining part of the rainfall falls on the ground surface. So some portion of the rainfall get into the soil, so which is known as the infiltration. So this infiltration water builds up the groundwater. So the remaining part of rainfall flows over the land, so which is known as the overland flow or the runoff, and which fills all the depressions, whatever the depressions on the ground surface, and finally which joins the stream. So again, the excess water from the stream, again it joins back to the ocean. Again the same process continues, that is evaporation and evapotranspiration, precipitation, overland flow or runoff. So it is a continuous process in nature. Now let us discuss the different forms of precipitation. So there are different forms of precipitation. The first one is the drizzle. A drizzle is a light steady rain. So the diameter of the droplet will be about 0.5 mm and the intensity of rainfall is about 1 millimeter per hour. So a drizzle is a small steady rain. So we have experienced this. Whenever we have a small rainfall, it is called as a drizzle, and the diameter of the raindrops will be about 0.5 millimeter, and the intensity of the rainfall is about 1 millimeter per hour. So next, the rain or the rainfall. The condensation of atmospheric water vapor is known as rain, and the diameter of the rain droplet is about in between 0.5 to 0.5 to it is 6 millimeter. It is not 0.6 millimeter. It is about 0.5 to 6 millimeter, and the intensity of the rainfall will be greater than 1 centimeter per hour. So whenever the water droplet having a diameter between 0.5 to 6 millimeter, it is called as the rainfall, and the intensity of the rainfall is about 1 centimeter per hour. Next, glaze. That is, whenever the rain drops are frozen, correct? Frozen rain or drizzle drops, when they come in contact with cold object is called as glaze. So it is another form of precipitation. Next is sleet. Frozen raindrops falling through atmosphere at sub-freezing temperature. So that means at minus temperature, whatever the frozen raindrops falling through atmosphere at sub-freezing temperature is known as sleet. Next is snow. Everybody know about the snow. That is water vapor condensed to ice crystal is called as snow. That is in Himalayan ranges, we have the snowfall. So that is nothing but the water vapor condensed to ice crystal. And snowflakes, ice crystal fused together is known as snowflakes. Whenever ice crystals are fused and it becomes a lump, it is called as snowflakes. Next is hail. It is small lump of ice crystal greater than 5 millimeter diameter and generally carried up and down by high turbulent wind or current. So this hail is nothing but, sometimes we call it as hailstorm. So it is nothing but, in Kannada we call it as alikal ಮಳೆಗೆ hailstorm ಅಂತ ಹೇಳ್ತೀವಿ. Here a lump of ice crystal having a diameter greater than 5 millimeter and it is carried up and down by high turbulent wind or current is called as hail, and it is also called as hailstorm. Next is dew. That is water vapor condensed to small drop on cool surfaces. You can see on plant leaves in the morning, you can see a small water droplet, so which is known as dew. Next is frost. Frozen dew drops are called as frost. So you can see a thin sheet of water vapor on the cold surfaces. So that is nothing but the condensation or the frozen dew drops are called as frost. And fog, a thin cloud formed at the ground surface due to condensation of water vapor. So these things we can see in the month of winter where you can have a fog. And mist, whenever there is a thin fog, it is called as a mist. Now, these are the different forms of precipitation, right from drizzle to mist. This drizzle is a light steady rain, and the diameter of the raindrops is about 0.5 millimeter, and the intensity of the rainfall will be less than 1 millimeter per hour. And the raindrops will be having a diameter in the range of 0.5 to 6 millimeter, and the intensity will be greater than 1 centimeter per hour. And glaze is nothing but the frozen raindrops when they come into contact with cold object is called as glaze. And the sleet is the frozen raindrops falling through atmosphere at sub-freezing temperature. And snow is nothing but the condensation of water vapor to ice crystals. And snowflakes is ice crystal fused together is known as snowflakes. And in the examination also, the question will be like this: what are the different forms of precipitation? So these are the different forms of precipitation. So sometimes there are different types of precipitation. The different types of precipitation is different from the different forms of precipitation. Normally students, whenever we ask what are the different forms of precipitation, they write the different types of precipitation. No. So these are the different forms of precipitation. Now, next is, these are the different types of precipitation. So there is a basic difference between the different forms of precipitation or the different types of precipitation. So we have already discussed the different forms of precipitation. Now these are the different types of precipitation. The first type is convectional precipitation, or it is also known as thermal convection. So the first type of precipitation is convectional precipitation, or it is also called as thermal convection. And the second type of precipitation is known as the frontal precipitation, and the third type of precipitation is known as orographic precipitation, and the fourth type of precipitation is known as the cyclonic precipitation. So these are the different types of precipitation, whereas these are the different forms of precipitation. So whenever we ask a question, what are the different forms of precipitation, you are supposed to write this, and these are the different types of precipitation. So anyway, I request all of you to mark your attendance in the chat box. So because time is running up, so I will continue the class on Monday. Hello, am I audible? I request all of you to mark your attendance in the chat box. ಕೇಳಿಸ್ತಾ ಇದೆ ನಾನು ಮಾತಾಡೋದು? Hello?
Yes, sir.
Okay, so mark your attendance in the chat box. So along with your name, please write your USN number also. So USN number ಬರೀಲಿಲ್ಲ ಅಂತಂದ್ರೆ ಅಟೆಂಡೆನ್ಸ್ ಕನ್ಸಿಡರ್ ಆಗಲ್ಲ. ಅನುಷಾ ಎನ್? ಅನುಷಾ?
Yes, sir. Yes, sir.
USN number ಬರೀರಿ.
ಬರ್ದಿದ್ದೀನಿ ಸರ್. ಅನುಷಾ ಎನ್ 4J18 CB094.
ಇದು ಯಾರು ಅನುಷಾ ಎನ್ ಅಂತ ಯಾರು?
ಸರ್ ಮೆಸೇಜ್ ಅಲ್ಲಿ ಹಾಕಿದ್ದೀನಿ ಸರ್, ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ.
ಸೊ ನಾಳೆಯಿಂದ ನೀವು ಲಾಗಿನ್ ಆಗ್ತಾ ನೇಮು USN ನಂಬರ್ ಇದ್ರೆ ಮಾತ್ರ ತಗೊಳುತ್ತೆ, ಇಲ್ಲ? ಹಲೋ?
ಓಕೆ ಸರ್.
ಜಾಮ್ ಸಾಫ್ಟ್ವೇರ್ ಅಲ್ಲಿ ನಾವು ಅಪ್ಲೋಡ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ನೇಮು ಮತ್ತು USN ನಂಬರ್ ಇದ್ರೆ ಮಾತ್ರ ಅಟೆಂಡೆನ್ಸ್ ಕನ್ಸಿಡರ್ ಆಗುತ್ತೆ, ಇಲ್ಲಾಂದ್ರೆ ಆಬ್ಸೆಂಟ್ ಅಂತ ಮಾರ್ಕ್ ಆಗುತ್ತೆ.
ಓಕೆ ಸರ್, ಓಕೆ.
Okay. So anyway, time is running out. So thank you so much for attending the class. So we'll continue the class on Monday around 30. I think Monday I have a class from 11:40 to 12:30. So we shall meet on Monday. Till then, have a nice day. Stay safe. Stay at home. Thank you. Goodbye.